Hi everyone, I'm back. This is the fourth video for the week, and we are going to work on a topic in your textbook, which is section 10.2, and this goes with your study packet on angles and arcs. And so those are going to be our main topic for this time. We're going to go over a couple of key concepts and reviewing some of the vocabulary. So you might want to have the vocabulary sheet that you finished Tuesday night ready and out. So you might make some notes on that, or you might just make additional notes. Either one's okay. This will be the last video for the week, and so you'll have to deal with my face next week. I just want to remind you, make sure these 4 homework assignments are ready to turn in on Monday, and that way you'll be all caught up on this unit. And when that happens, we'll only have 6 weeks to go, so that'll be pretty exciting. Okay, angles and arcs. Angles and arcs. The first key concept is when you have a circle, all right, and you start putting angles around that circle like this. You have several angles, angle 1, 2, 3, and 4. Then those angles add up to something. Can you guess what they add up to? Pause the video, think about it. What do they add up to? And your answer should have been the angles around the center of a circle add up to 360 degrees. Now that's important. If we don't know a missing angle, then we're going to be able to find it. All right, another application that we want to make sure we know about is arcs and arc measure and how to compare those things. And so the vocabulary is, we talk about what's called a minor arc, a major arc, and a semicircle. And so just so we know those things, let's start with what I think is the easiest one, the semicircle. A semicircle is an arc, we'll say from A to Z here. It's an arc, watch how I trace it. It's an arc from A to Z, or an arc from A to Z. Essentially, it's the arc that creates half a circle. Now, a minor arc is going to be an arc like arc AB or arc BZ that are less than half the circle, or less than a semicircle. A arc that is bigger than a semicircle would be like arc AZB. So now we're going all the way around this way. That arc is what you call a major arc. Okay? Now, arcs are always can be labeled in certain ways. So a minor arc, I would write arc AB, and I put a curve. For instance, if I was labeling the chord would be chord AB or line segment AB. The arc, I then put the curve. So that would be the minor arc. The major arc, I can label arcs with 3 letters, and usually I use 3 letters when I'm indicating a direction. Minor arcs could also be labeled with 3 letters. For instance, if this was a C, then the minor arc ACB would also be the same as the arc AB. You could also label arcs in reverse order. So for instance, I could have had the arc BZA, and that refers to the same arc as this. Okay? So pause. Make sure your notes are complete on that, and you're ready for the next thing that we do. So, welcome back. The next thing we're going to do is we want to decide when are arcs going to be equal in measurement. All right? When are arcs going to be equal in measurement? Well, arcs are going to be equal when their central angles are equal. So for instance, if I have a central angle here that's 80 degrees, and then I have another central angle that's 80 degrees, then I know that arc AB is congruent to arc BC. Arc AB is congruent to arc BC since 80 degrees equals 80 degrees. So that's a nice feature. That's a theorem that says that arcs are congruent if and only if their central angles are congruent. So the next thing that we want to do is we could add these angles to get 160 degrees. So what's that mean about the arcs? Well, it turns out we can add the arcs as well. So if this angle is 80 degrees, then this arc is also 80 degrees. If this angle is 80 degrees, then this arc is 80 degrees. And the sum of the arcs, the measure of arc AB plus the measure of arc BC, is equal to 80 plus 80, or 160 degrees. And a consequence of this is, a few moments ago we talked about how all the angles added up equal 360. Therefore, all the arcs added up equal 360 degrees as well. Okay? So, pause a moment, make sure your notes are clear off this video, and then we're going to do a couple of problems. So here we are to the second part of this video, and for your homework tonight you're going to work on some algebraic things with arcs. So for a couple of examples we're going to do a few examples. So here's the first one. I have a circle, and I have this, and we'll draw this radius here, and we'll draw this radius here, and this is 150 degrees, and this angle's 85 degrees, and this is a right angle. So the question is, what's the measure of that angle? And so we can see that these angles are all the angles in a circle, and that they need to therefore add to 360. So I know 360 equals x plus 90 for the right angle plus 85 plus 150. And when I add those together, I get 360 equals x plus 240, and 80 is 325. And then to finish the algebra, I subtract 325 from both sides, and I end up with 35 degrees is equal to x. So the measure of this angle is 35 degrees. And this is a very typical problem where you want to find the measure of a missing angle or two in a problem. So let's look at the second kind of example using the second idea, which is finding the measure of minor, major arcs or a semicircle. So for instance, here's a circle, and we're going to label it. So we have A, C, D, F, G. Make D a little bigger there. And then we have a few measurements. This is 35 degrees, and this one is 55 degrees. And so what we would like to do is we would like to find the measure of different arcs. So for instance, if I said find the measure of arc CD, well, the measure of arc CD is the same as the measure of its central angle. So its central angle is 55 degrees. So this would be 55. And that's pretty much how you have to do the problems. You have to go through and just find the central angles. So what I'm going to do is I'm going to show you a strategy for how to do this kind of problem a little bit more simply. And so here's how you want to do that. So pause, and I want you to think about how you would do this problem, and then I'll show you a strategy you can use. So pause for a sec. So just think about that. So here's how you're going to do this problem. The strategy is use the semicircles to help you. As you can see, AD is a diameter and CG is a diameter. So use known information to make a problem easier. And what I know is that a semicircle is half a circle, and so half of 360 for the angles is 180. So when I look at AD, this semicircle on top is 180, but I already know 55. So if I take 180 minus 55, that will give me 125 degrees. So that is this angle. And if I know 125, or even better, if you look at this, these two angles are vertical angles from the first month of school. So this is 55 degrees. And now, all I have to do is find this angle, but 55 plus 35 is 90. And so 180 minus 90 is equal to 90 degrees, and that's the last angle. And if you check, these should all add up to 360 degrees. You can check it on your own if you like. So now we can do the other arcs. So for instance, what's the measure of arc AC? Well, the measure of arc AC is 125 degrees. Let's do a harder one. What's the measure of arc CDF? Well, the measure of arc CDF is these two angles, 90 plus 55. So it's 145 degrees. And you can start to play this game all the way around. Just begin to do the individual angle with its central angle, or the sum of several angles to get one angle. So let's do a major arc just for the fun of it. How about arc CAF? All right, so it's CAF, so that's these three angles added together. 125 and 55 is 180, plus 35 will be 215 degrees. And so as you can see, the strategy is find all the angles first using the semicircle, using the ideas that we know from about vertical angles, right angles, etc. And you can see that all that information on right angles is going to help us to do problems that involve angles, and then that will then help us to find arcs. So that's your lesson for this week, and you should be able to do the rest. And we'll pick this up on Monday. Thanks for watching the videos, and then let me know how you like it. See ya.